And I'm going to introduce Jim. And I really need a paper for this, because if I don't read it, you'll believe that I am inventing it, because he has one of the most surprising and interesting background that you will be able to see. And I'm very glad that he's the speaker we selected to be between you and your lunch, because you see, when he shares his passion and his vision, you're going to forget that you're hungry, trust me. Let me tell you more about Jim. And I'm reading this because I can certainly not invent it. Jim is a yak herder who spends most of his time on the edge of technology innovation. So Jim, you'll have some explanation to give us about the yak herding here. His roots go back to the original team that created and sold DOS to Microsoft in the early 80s. He developed the first PC-based database to run on LANs and pioneered several startup companies throughout the 1990s. In 2000, he joined Amazon.com, where as a VP of technology, he built their third-party reseller marketplace platforms, which is a leading business for them. And recently, so at CODONiS, is leading the efforts to create the clinical cloud fabric, which he's going to tell us more about today, as well as he's a CTO of Sabey data centers, where he's innovating on end users' data center solution by providing network provisioning capabilities to optimize data center resource management, which is the topic of this session. So please help me in welcoming Jim for the second part of this session.
We're not going to talk about yak herding in this session, maybe another one. We're going to talk about where SDN is going. And if you look at Schumpeter's creative destruction, great economist, Austrian economist, you look at how major disruptions happen. And I see SDN as an enabler, not the disruptor. And where the disruptions are going to happen are new kinds of networks that are going to occur. So everyone in this audience are going to be part of creating these new networks, which are going to be exciting. Internet's been around a long time. It's a great network. But lots of new networks are going to get created throughout this. So I'm going to talk a little about who we are, give you a market perspective from the data center view, get an example of a focused on an enterprise solution, a very, very large one, describe how we look at SDN, how we would define it, and then Isabel asked me to do a real-life example. I'm going to delve into a little biology here for you at the very end. We're the largest private data center business in the country, 3.5 million square feet. Got into this about 12 years ago. Been a good business. Data centers is booming. I'm president of CODONiS, and we're in the bridging world of healthcare and life sciences. There's so much happening in life sciences and healthcare that we're decided to go after that as a network cloud technology. And we're also working closely with Sabey to manage their cloud services and network management services. Until recently, Sabey had not been in the network side. We're seeing this as a huge opportunity. In terms of data centers, we consider ourselves sort of a dirt to cloud business. We actually own the real estate, we own the rebar, we build the concrete, we build the buildings, we run security, manage all the construction, and now we're doing network management as part of that. Networking has always been sort of a second-class citizen inside the data center. Of course, we got layer 1 coming through, but we should be doing more interesting things inside. So we decided to take this head on and are having some good times looking at how this should be done going forward. In our 3.5 million square feet, on the West Coast in Seattle, Tukwila, we have a 75-acre campus. One of the buildings there is actually 15 acres itself, probably the largest data center on the West Coast. And then we decided to strategically locate some buildings, some data centers onto Eastern Washington. So Washington has got two sides to it, Western Washington, Eastern Washington, and there's 2 tectonic plates. So we've got an isolated tectonic plate that's very calm on Eastern Washington in Quincy. Plus we have dams. We got the largest dam system of any state, and we got 2-cent kilowatt power. So if you want to have dense computing and storage, that's where you want to put it. Then we decided to create networks between those, and the story gets more interesting as we go. Last week, if you looked at MSN, they had the 10 ugliest buildings in the country. One of them was the Experience Music Project by Paul Allen in Seattle. But over in New York, where we got a couple $100 million of investment, we bought this building here. We call it 375 Pearls, known as the Verizon building. 32 floors, one of the highest data centers, but it's traditionally been a telco business. You know, the 14-foot frame switches, floor to ceiling, all out to the top of that building. Moore's Law happened to put that down to 2 floors, so we wrote a check and bought the building. We decided what we want to do is build the densest network topology-oriented data center on the planet. We want to put it right there in Manhattan. Got lots of business to do there. So we invested there. And we're building in Ashburn, Virginia, similar to like Seattle and Eastern Washington. We want to do New York and Ashburn. And we're building networks between all these centers. So we have a market perspective that's interesting. We get to see everything. I mean, if you're doing something in a data center, we know what you're doing. We talk to them, we give expertise. So everything from cloud ISPs, financial software companies, healthcare, education, government, everything. And it's just piling up. More and more and more are going to data centers. And some of the biggest companies, Microsoft, VMware, you name it, go down the list, they're in our buildings. And they're strategically located because of power, because of network access, because of security, tier 3 type buildings. And we established a great relationship on how to manage these data centers. So we're working this from the scale perspective, very large databases. And an area that's particularly interesting is healthcare. Life sciences is interesting because there's lots of technology there that we just sort of overlook. I'm going to get into that a little bit. And look at life at scale and how networks work. But in the practical, everyday, what's happening in the market in data centers, which is really important, is healthcare. And that's what we'll take as our example focus here. We're working with Providence Health and Services. They're based in Seattle. They're in 5 states, been around for 150 years. So they're quite experienced. We've had 30 hospitals with data centers all around, and we worked with them to consolidate into 2 buildings, a primary data center and a disaster recovery high availability center. So we did that in Seattle and then in Quincy, Eastern Washington. And as we got to know Providence and spend time with them, we realized they're a great institution. They're top 10 easily in the United States. The VA is the largest at about 40 billion, but they're at 11.6. So they're significantly large enough to have a very good perspective on IT, networking, and cloud. They got 65,000 employees, 1,800 IT staff. They came to us and said, okay, well, we consolidated. Now what do we do? So once we did the data center piece, we thought, well, we got all these disparate locations. We need to look at disaster recovery and high availability. What if something bad happens? What if a rock hit the building? You know, a big rock. What do you do? So we got into a disaster recovery and high availability mode with them. We spent more and more time with them. And in the process of all this consolidation, you know, I personally spent time in the racks looking at what they were doing and how they did it. I saw that they took all their locations and they put them in one big room, and they really didn't change the network topology much. So what's going on with that? Why did you do it this way? Well, just time and pressure and moving and so forth. And healthcare companies, they don't really have chief technology officer types. They have chief information officers. They're moving information. Their primary objective is to work with reducing healthcare costs and getting to patients and applying point of care. They don't really have chief technology officers. So I kind of moved into and acted in a CTO-like mode with them and said, well, why are we doing things this way? And we really looked hard at this situation and said, okay, well, we've done your data center, but and we've been managing your cooling, your cooling, your power, security. What if? I'm an entrepreneur. It's my 13th or 14th company. I like technology, and this healthcare thing just got me. And I realized that what if we managed the entire system? Like the network, everything. The metro carrier grade Ethernet, everything, end to end. What if we did that? So we talked to the head of Providence and told him what we thought we could do. Maybe we could do the Amazon thing all over again, but do it in healthcare. Well, it's a really hard thing to do. I like hard challenges. They like hard challenges. It made sense. So we looked at this market and said, you got $2 trillion in revenue coming out of hospitals. It's 18% of the GDP. They're spending $60 billion on IT and staff and products, services. What's going on here? You got 4,000 hospitals. And you look at this whole equation and you say, everybody's doing the same thing in every single hospital, IT, building, everywhere in the country. You look at that and you say, well, that's opportunity. There's a way to change this, to make this more interesting. On Amazon, when I was there, we'd been selling books and music and kind of consolidated, disrupted that business. And then Jeff Bezos asked me, we need to be able to sell shoes and yak cheese and literally and lapidary saws. Let's sell everything from everyone through the system. So we built a third-party reseller platform called Merchants at Amazon, and we lit that up, and it's scaled. It's more than half their business now. We didn't sit and look at, well, we're doing well in books and music. We decided to go after everything. And now Amazon has gone into the cloud and doing great in that area as a public cloud service. So when we look at healthcare, you say, well, this is really big. This is bigger than e-commerce. This is the biggest market out there. What should we do with that? So our solution was to create a joint venture. And it's a joint venture between CODONiS, the cloud services company, and Providence. And let's take this whole IS system and turn it into a technology platform services. And what we wanted to do is build a multi-tenant healthcare cloud. And I kept on saying, this is a networking issue. This is not a traditional cloud issue, if we can call it traditional cloud traditional. This is more of a networking orientation to this thing, because hospitals are, by nature, completely distributed. So there's a first-generation cloud that's out there now where you've got this centralization, but what's coming is this full distribution. And the reason I say that with confidence is because life is fully distributed, and I'll get to that in a second. So we wanted to re-architect their network to support multi-tenant operations. They're a Catholic organization that has a mission, and their mission is to serve others. But when we started talking about it rather humorously, we said, well, you're only serving yourself. You're building all this IT just to serve Providence. Why don't you serve everyone? So we took that mission from 150 years ago and said, now let's take this and serve everyone. To do that, we have to create a platform, not just have an IS system. So we're going to run all applications as a service from this network. And then we're going to sell those applications back to Providence through the joint venture. And then once we've got that working, we'll sell that to everyone, all hospitals that want to reduce their cost in healthcare, IT. We're looking at this as a 65 to 75% reduction in cost over 10 years. At that rate, we've significantly reduced this so hospitals can focus on what they do best, which is point of care. And we want to have new customers, new healthcare providers, clinics join our network because we'll have figured out how to do this. Disaster recovery. If you look at Gartner's look at high availability, it's like 8x times whatever your primary system. It's like 8 times that to get high availability running. Well, hospitals can't afford that. Very few of them even have disaster recovery at all. It's typically in a notebook somewhere. Here's what happens if the hospital or the IT system goes away. It's a notebook. That's not going to do it. So we're looking at economies of scale with disaster recovery and high availability at a fraction of the cost on what it would cost. You just try to enter that game. So we're building this new network, and I call it a clinical cloud fabric. And we looked around trying to find, where's this, I was looking at SDN, it looked interesting, and where do you get this stuff? I need a fabric. So we went to Juniper first and said, let's put QFabric in. So we put QFabric in, which is this 5 microsecond flat network. Great idea. Now let's go extend this. A typical hospital can't just go put in these relatively expensive systems on their own and say we're going to go to scale. They can only do what they can do. So we're trying to offer this as a service. It's actually a top-of-rack service. Our contracts with our customers now have top-of-rack service in our contracts. It's a good thing for networking. We want to extend these top-of-rack services out to the customer prem. So while we do know that data centers are getting larger and cloud is getting bigger, when you think about hospitals, the prem is where the action's going on. The doctor in the home or at the clinic, these instruments that are being used, these new high throughput DNA sequencing machines all around this network. We need to be at the edge. We need to have the cloud at the edge. So this is how we're sort of re-architecting the network. And what we want the cloud to do in our view of the world is to provision ports, provision the network itself, provision across the layers. So the SDN for our needs, we look at it as programmatic orchestration and provisioning of network resources and optimal secure flow between applications and services. I'm not sure that's good enough for this audience, but that's how we look at it. That's what I want. Cloud gives us orchestration and provisioning. We need that for networking. Ports, storage, cores, it's all the same thing. Let's manage it the same way. And it's moved in that direction. So SDN allows us to create new network types and applications. That's the key here. It's not that SDN is this massive disruption happening in the industry. It's an enabler for us to disrupt by us creating new network types. We need new network types to solve new problems. Healthcare needs a new network type. And SDN is how we manage networks at scale. So we can go through a number of arguments that, yeah, I can do this without SDN and so forth. We all know that. Go through the list. Let's make this implementation. We can do that. When you're talking scale, multi-tenant, multi-site, high availability, disaster recovery, applications that are going to be provisioned quickly, networks that need to be provisioned quickly, no. There aren't enough network engineers in the world to satisfy the demand if we have to go quickly. We need to provision very, very quickly. So SDN to me is this orchestration provisioning with the flow and dynamics and intelligence built into it. We look at this next generation network cloud coming. First generation clouds are centralized, large resource pools, remote. And the larger they are, they're exclusively in large data centers. And that's fine. Many of these cloud companies are in our data centers. But the next generation cloud is interconnected networks of networks. It's distributed, scalable, managed fabric of data centers, networks, and resources. That's where we're going. That's how life works. I know we're technologists, and we get that. We're working in a binary digital world. But where biology is extremely distributed and efficient. And it would lead me to believe that's where we want to go. So SDN-based solutions where, hey, it's programmable, it's adaptive, and it's secure. That's good enough for me. And if we can orchestrate and provision, then we've got a complete solution. So healthcare requires this distributed model. Consolidated server resources and data centers. Of course, we have to have that. It's efficient to do that. Distributed locations of hospitals and clinics. Well, not all the action is going on the servers in those data centers. A lot of the action is going out at point of care. How do we manage that? What are we doing right there where the network is touching that device with that doctor and that patient? What are we doing there? It's not some remote location. There's stuff going on right there. We need to manage that. So we need to distribute our edge resources, all these type of products that we connect to it, and we need to manage it securely. So in a managed services realm, for data centers, yeah, we got power, cooling, security. We get that. We've been doing that for a long time. For managed networks, we really want, if you will, one programmable virtual extended network. That's how you want to manage a whole system like a hospital with 30 locations. You want to run through the layers 1 through 3. We want to do optical cross connects inside our buildings coming up. I don't like the whole meet me room concept. It's been around a long time. Patch panels and it's fine, but it's not good enough. We should be doing intelligent routing of carrier rates and so forth. And then we want to move that optical cross connect up into the layers of the building. So at our 375 Pearl, that Manhattan building, those 32 stories, we just want that as one single layer across the entire building if we can. Offer those services and see if we can beat the price in which you would have to go do yourself. And if we can, then we can start changing the way the economics work inside these data centers. And of course, disaster recovery and reliability have to be built into the overall fabric from the beginning. Now, managed resources, typical cloud stuff, but I want to add, so it's cores and it's stores and it's ports. And when it comes to healthcare, we're not going to push a button and everyone's going to take their hospital system and move it to the cloud. It's just not going to happen for a number of reasons, for too many reasons. I was a bit naive when I first looked at it. I'm still naive, but when I looked at it, there are too many reasons why that's just not going to happen. And so there's these buckets of own, managed, and virtual. So in healthcare, what we see today is a big owned asset base of resources. They got their servers, and they got their tapes, and they got their SANs, and you name it. They've got everything. And they buy everything. And the vendors come to them, and they just keep buying stuff and adding it up, and they put it in these data centers and closets and so forth. And very little is managed and very little is virtual. Tomorrow, where we're going toward is a managed network. It has to go this way because inside that managed network, you can then expand what is managed, expand what is virtual. Managed, I mean, we work with you inside the data center. We'll bring network and so forth. Virtual, it's all remote. And we have cloud services doing VMware and OpenStack. That's the world we're going, where the network is really the key to this whole thing. It's not some distant cloud. It's the combination. You have to look at your enterprise and you say, what's a spreadsheet look at? Do I want to put 4 petabytes into Amazon? I mean, does that make sense? Amazon's great for certain things, and there's mixing and matching. But when it comes to the hospital, it's a managed network we want to go. So it's owned resources, managed resources, and virtual resources. So in data centers, managed data centers, you got large tier 3 data centers. We got data centers on the premise in the hospital. We got clinic data centers, large and small. For this distributed scalable managed network, at layer 1, 2, and 3, different things are happening. Those need to be managed. And if you look at a large enterprise like a hospital, is it their expertise to have the very best network engineers on staff? The better that you have, the better it is for your organization. But they're not optimized to do that. Companies like ourselves, people in the audience here, are optimized to go build technology so they can plug into it. And so there's a lot of inefficiency in these enterprises by trying to manage all this stuff. If you think about all these 4,000 hospitals, how many network engineers are deployed doing the same thing over and over? Are they doing the optimal solution? We don't think so. And in terms of resources, again, the owned and managed, it's all integrated across the data centers, networks, and the resources. So let's talk about a specific problem here. The head of Providence came to me and said, do you know about Sutter Health? Well, they got a $1.6 billion violation from a HIPAA violation. And so one of these regulation type things that could cost them quite a bit of money. And the reason is somebody went into the hospital, and it wasn't a laptop, it was actually a desktop, and they took it out, and something bad happened with all those names and addresses. And he asked, well, we got 75,000 desktop laptops, iPads, and so forth. Fix this problem, would you? And so we looked at that and said, all right, firewalls are great and everything, I get that, but they're not pure in terms of the sense of networking. They're sort of an aberration, and we have to work with them. And then I talked to the security people at Providence, and smart guys. The problem with security is this. They're faced with 22 things they have to do. And those 22 things they have to do, a large list of here's all the things you got to deployed everywhere. So good luck getting 22 things deployed everywhere across your network. It's not going to happen. So security, based on its own definition, it makes it insecure. And so we looked at this and said, what if we were able to control a very intelligent network and manage things that way? Isn't that the way to do it? When IPsec came out, that was pretty nice. A lot of arguments that went on for many years about that, but that's a pretty elegant solution. I mean, that's a network solution at the transport IP layer. That's pretty darn good. That's where we need to be going. That's why networking is the most critical issue here in this next generation cloud. It's not a second fiddle type thing. It's really crucial that we understand how to manage and orchestrate these resources this way. So we come up with an idea called distributed virtual isolation, meaning that every device in a hospital is distributed. Okay, servers are inside a data center. That's fine. You get thousands of those. And you've got, at the prem, you've got stuff. You got stuff at people's homes, you got desktops, you got iPads, you got people moving all around. So we looked at that and said, let's first of all manage these resources. And so you can do things with interesting virtualization on the machines. You can protect the machines. You can turn storage on and off. You can turn ports on and off. So we looked at that and said, let's do a secure network overlay across all of our resources. And then let's take that and do a secure network overlay with our switches in the virtual layer. And let's put an intelligent IPsec type situation here. Now, for the first time with SDN, we can actually do some really interesting key management with IPsec. And the great thing about that protocol is that it's dynamic. And SDN is nothing if it's not dynamic. And because it's dynamic, we can move stuff around wherever we want. We can turn ports off. We can say this person moved from this part of the clinic to the Starbucks outside. We noticed that. This desktop was moved out. It's no longer in use. You know, we can put encryption everywhere and encrypt the disks. I don't like that. I like more of an IPsec solution where you got a simple, elegant solution that's dynamic, it's intelligent, and you don't have 22 things you have to shove onto your users and say, well, do this and run this and put this key in and do all that. It's not going to work. It's by nature of that insecure. So what we need to do is do secure solutions using SDN because you've got intelligent access to the network and everything moving around. You know where everything is, and you can turn things on and off. So that's a solution we're working on. And then lastly, I want to move, Isabel asked me to do a real life example because we've had some conversations on the phone. She thought it might be useful. Life itself is not hardwired. May not sound obvious, but it should be. Life is actually instruction-based. It's what's called dynamical. And I'm going to take you through a quick little realm here because everything we're talking about, the last thing I talked about with SDN was all about instructions and dynamicalism and intelligent change-up on that network and protocols. You know, we've got hormones running all throughout the system doing all kinds of things with us right now. I'm talking about, well, I won't get into all the different kind of hormones, but I'm talking about the hormones that just make you function with your metabolism and so forth, just to keep you maybe interested in this topic here. So let's get into this. So first of all, we got symbols, we got nucleobases. So everywhere in science, go back to Newton, F equals ma, his second law of motion. All those symbols were in our mind. And we all agreed that's how physics works. And then we got Einstein in 1905 was really interesting because E equals mc squared, all these derivations, he basically said matter and energy are the same. Well, that's good. He figured that out. We agree to those symbols. But in life, there's something different. All those symbols we talked about are abstract. Nucleobases, they're physical. And they're immaterial. They're actually instructions that exist in the universe. They're there. You can look at them. We don't have to agree. They're there. From those symbols, we have codes, the codons. CODONiS is a derivation of codons. Codes are the bits that are used in the instructions, which we have organized codons. No one understands a single instruction in life. Not one person. I spent some time with Craig Venter yesterday, who's the one who's created the new bacteria species, Mycoplasma laboratorium. Spent some time with him and said, Craig, you know, those instructions, those genes, we don't understand that, right? Right, we don't understand that. Problem is it's in base 64. Get into that in a second. So we got symbols, codes, instructions, functional units, proteins and organelles. We got functional systems like cells, organs, and firewalls. You know, the nucleus inside us is a firewall with 4,000 holes on it, ports, and it prevents certain things from coming in and certain things from going out. We got functional networks. We got optical systems. We got electrical systems. We got all these protocols running our bodies. And at the organism level, like the mycoplasma or the human, and then the ecosystems. So this is all working and integrated. It's been working for quite a long time. If you look back in history, the DNA, still version 1.0, 3.6 billion years later. No changes. No 4 more upgrades. Those nucleobases are still sitting there. The codons are still sitting there. Proteins are still being created. All that functional stuff still working. The x86. Now, I happen to work with the first team that did MS-DOS. And we went down and picked up a 1979 Circa 8086 from Intel and wire wrapped the S100 board, put it in a bus, and built an MS-DOS thing and called it good. That's evolved slightly over the last 33 years. You know, we got virtualization, that kind of good stuff in there. But DNA hasn't changed. 8086 instructions. We all work in a digital world that's binary. But DNA is base 4, quaternary. And the proteins themselves are actually base 64. That's on a logic level that we really can't contemplate. And that's why Venter was having difficulty on this instruction question I had yesterday. When we look at digital networks, we're just beginning to provision dynamically. So SDN's about this, you know, if I could underline one thing, it's the dynamic provisioning and orchestration of this stuff. That's where we need to go. It's too hard doing it the way we've been doing it for so long. This has got to change. Life networks have been dynamical since the beginning. We got 100 trillion cells in our body. If you take your DNA, extend it, wrap it around the Earth, how many times? 4 million times. 4 million times. Okay, that's all instructions. The same instructions are repeated over and over, but they're distributed, fully energized. There's energy built into DNA itself. And all cells have to have blood and oxygen now, and it's working. About 40 billion proteins in each cell. And this DNA is actually a runtime, 17-dimensional geometry that's at runtime changing all the time. It's an area called metagenomics, which is how DNA modifies itself on the fly. Inside the biology, we have virtual networks. What's called a protein-protein interaction. It makes humans different from every other more complex, able to think, more complex organism, not by the size of our DNA, but the number of proteins that interact in a network. These are virtual networks that are derived on the fly on all these proteins. We have 23,000 proteins in our system, different types, and they communicate. That network is huge, and that's how it works. When you look at controllers in SDN, what you have is the network of all the places where we're trying to figure out where things are going. That's a PPI type thing derived. We've got dynamical networks, microtubules. In your brain, the most prolific protein is tubulin. And these are built into networks that build on the fly, on demand. When I need a network that goes from this part of the cell to that part of the cell, I need to move 1,000 proteins from one section to the next. That network didn't exist until it was needed. A microtubule is put together instantly. We have optical networks in the optic nerve. It actually has mitochondria on it. It actually carries energy with it. We don't have networks that carry energy with it. We should look at that. We got cross connects. The central nervous system and the peripheral nervous system is this major cross connect. You know, the actual central nervous system is embedded in bone, and the peripheral nervous system is out there with electrical contact and conductance. We have broadcast networks. So the antidiuretic hormone, which is started in your hypothalamus and your pituitary, dropped into the blood, goes through is broadcast through your blood system, and you have these binding proteins on your kidneys, so that when you decide to go grab your glass of water, which I don't have right now, which I wouldn't mind having, it releases that binding, and it allows you to take that water and so forth. So we have all these networks, and ultimately it's all autotonic. And it's like you're not, in this autonomic networking, you don't think about it, it just happens. That's where we need to be going with the way we build our networks in the future. And life is nothing if it's not software defined. So I want to underline that point. So enabling enterprise SDN, like life, it needs to be, I would call it has to be instructionable. The more we get to instructions, and even though instructions are in firmware and hardware, the more we make it out there. You know, computer scientists, we like to take things, abstract it, and then put it to scale. Right? That's what it's all about. Have a concept, abstract it, put it to scale. Our job is to abstract it, these instructions and these controllers and so forth, separating the data plane, the control plane, and these controllers to manage all this thing at scale, but make it instructable, make it orchestratable, see where everything is, be able to know where it is going, provisionable, build them when you need them on demand, like the microtubules, if one day we could. Make it securable. So anything you're working with is always secure through some defined protocols. And lastly, make it distributable. It's not all in some centralized place. Yes, we do data centers, but we realize that to solve these problems, we need new networks to get to the full distribution level. Like life, everything is distributed. And that's how we're looking at it. We have large-scale enterprise data centers. We're connecting them together. We've got huge, great clients. We're doing joint ventures with them to try to change the industry. And we're looking at the way networking ought to be done in the future. And I'm just happy to be among this group to learn where it's going. Thank you.